Hi everybody, today we're going to be talking about factoring trinomials. This is day 4. So yeah, let's just go ahead and get started. Okay. So, quick review just about factoring out of GCF. We have a binomial. Typically all we can do is factor out of GCF. Same thing with trinomials, so you're going to have to do that again. But we just want to practice this. So, when we factor out of GCF, our greatest common factor, we're trying to find the biggest number or numbers that they have in common that we can take out and kind of like reverse distribute. Okay, so if we look at 2x squared minus 4x, there's two parts. There's the number part and the x part. So we need to look at both. So starting with the number part, what can we take out of 2 and negative 4? Well, what do 2 and negative 4 have in common? They both have 2 in common. Oh, didn't mean to show that whole thing. Oh, gosh. All right, they both have 2 in common. So that's what we take out in the front. And when we fill in our parentheses, the leftovers, we kind of just divide it. So 2 divided by 2, if we take that 2 away, we're left with a 1. Negative 4 divided by 2, we're left with negative 2. Okay? Then we look at the x's. I don't know what that sound was. We look at the x's. We have an x squared and an x. What do they have in common? Well, they both have at least an x. So we can take away that 1x and then just write what's left over. So if you have x squared and you take away that x, meaning you're dividing it by x, you're still left with an x. Whereas you have x divided by x, you're left with no x's anymore. So this is what we have now. This is factored. 2x times x minus 2. That would be what our simplest form would be. That's not simplest form. Factoring is actually undoing simplest form. So we're creating another step here. So factoring, that's our factored form is what I'm trying to say. Okay? So let's go ahead into factoring trinomials. These directions are going to seem very, very confusing until we actually do them. Once we put them to a problem, it'll make more sense, okay? So just for right now, just write them down so you have them, and you can refer back to them when we do problems, okay? So to factor a trinomial, our step 1 is to factor out the GCF first, if it's possible. So there are going to be some trinomials where they don't have a GCF. So if they don't have one, you just skip this step and move on to the next one, okay? Step 2 is to factor by grouping, okay? This is a specific way to factor a trinomial. It basically just draws it out so it's into a polynomial rather than a trinomial, and we can do GCF factoring and split it into binomials. So it's a little bit easier in my opinion. However, there are other ways to factor a trinomial. If you guys want to research it, I know of another way. If you guys want to hear about it, just come talk to me and I can let you know, okay? But in my opinion, factoring by grouping, and my experience as well, students like to factor by grouping a little bit better, so I'm just going to show you that way. Alright? So let's go ahead, now the second step is to factor by grouping. Let's figure out how to factor by grouping. Okay? So factor by grouping, typically your trinomial is going to look like this, where a is a constant, your leading coefficient, b is a coefficient for the x term, and c is just your actual constant. Okay? So that's what it typically looks like in standard form. That is a general standard form for a trinomial. So what we're going to do is we're going to work off of that for this step by step. I'm just going to show you the general form. Okay? So step 1 is to create a magic x. So this is what a magic x looks like. It's basically just giant x. It's a way to organize your thoughts. That's all. So in the top part here is going to be the number you get from multiplying a times c. Okay? And in the bottom one is just going to be your b coefficient. Okay? Now your whole point is to figure out two numbers, okay, and those will go on either side, that will multiply up to this number, but add up to this number. Okay? And again, and this will make sense when we do it. Okay? So, but that's the whole point of the magic x. It's basically just a way to organize your thoughts to try to find those two numbers. Okay? Step 2 is to replace the b that we actually have, b coefficient, with those two numbers we found in the magic x. So instead of having bx, we could have like 2x plus 3x instead of having a 6x or something. That wouldn't make sense, but so we're just going to replace it and make it into 2 terms rather than 1, and that way we'll have 4 terms total and we can group them together. Okay, that actually draws me into step 3, is to group the terms. So when we write it out, we'll have this. I can't move this. ax squared plus something x plus c. And then from there, since we have 4 terms, we can just group them into 2 binomials and do it that way. Okay? Now once we have those groups and we have binomials, we can factor out a GCF really easily. So they'll have something in common, probably an x, maybe a little bit more depending on the coefficients. Back one will probably just have a number depending on the coefficients. So you need to factor that out. Okay? Then what you're going to do is you're going to be able to write it into 2 binomials. Okay? I don't know why that went away. Okay? So let's go ahead and do an example and apply this, and this will make more sense. So here's an example. Factor 2x squared minus 9x minus 35. So your first thing you want to do is see if there's a GCF. Is there a GCF between 2x squared, negative 9x, and negative 35? There's actually not. So, no. So we're going to go straight into factor by grouping. So step 1 is to make my magic x. Okay? Now, up here on the top is what I get from multiplying a times c. And just in case you weren't sure, that's my a, my b, and my c. So I'm going to be multiplying 2 times negative 35. It gives me negative 70. And then down here in the bottom is just my b, which is negative 9. Okay, so I'm trying to find 2 numbers to replace b with that'll multiply up to negative 70, but add up to negative 9. Okay, this could take a little bit of time. You probably will spend a lot of time with your calculator on this, and that's okay. Please do it. I'd rather you come up with the correct numbers than guess because you think it's going to take less time. Okay? So we need to come up with 2 numbers that add up to negative 9 but multiply up to negative 70. My trick is to come up with the things that multiply together to get negative 70 first, and then see if they add up to be negative 9. So negative 70, we could do like negative 7 and 10, which would give me 3, not negative 9. You could also reverse the sign and get negative 10 and 7, but that would just give me negative 3. So maybe I could do negative 35 and 2, but that gives me negative 33. Or I flip it and it would give me positive 33. So that doesn't work. How about 14 and negative 5? Well, that will give me 9, not negative 9. So since it's only the sign that's the issue, let's try flipping the signs. What if we had negative 14 and positive 5? Negative 14 plus 5 would give me negative 9. So those are the 2 numbers that I need to come up with. Okay? So what I'm going to do is I'm actually going to replace this negative 9x with a negative 14x and a positive 5x. So I'm just stretching it out into 4 terms. This is like when you guys multiply binomials together, you tend to get 4 terms and then you combine them to make it into a trinomial, right? So we're just kind of working backwards, okay? Getting our 4 terms. So now I'm going to go ahead and, I already replaced the b, so now I'm going to go ahead and group it. So here, the first 2 terms are always grouped together, the last 2 terms are always grouped together, okay? So now I have 2 binomials that are being added together. I'm going to factor out the GCF from each of them. So this first one, what can I take away from 2x squared and negative 14x? Well, they both have a 2 in common, that they're both divisible by 2, so I can take a 2 out. And they both have an x to spare, so I can take an x out. Okay? Oh, I did too much there. So I get a 2x, and I'm left with x minus 7 here. 5x and negative 35, they only have a 5 in common, so that's what I can take out of both of them, leaving me with x minus 7. Okay? So the red is what I've taken out, the black is what's left over. Do you see how the blacks on both of them are the same? So when that happens, and that's what you want to happen, you can basically create your 2 binomials by undoing this distributed property. It looks like the x minus 7 got distributed. So if you undo that, you'll be able to create your 2 binomials, saying x minus 7 times the leftovers, the red, the 2x plus 5. And that's your factored form. Okay? Those are the 2 binomials you multiply together to get that original problem. And you can always check your answer by multiplying these back together. Okay? So now you're going to try 2 on your own. This first one as well as this one. So starting with this first one, you want to ask yourself, is there a GCF? Well, yeah. 8, negative 24, and negative 144 are all divisible by 8. So you want to take that out. So now you have 8 times k squared minus 3k minus 18. that k squared minus 3k minus 18, that's what you need to do factor by grouping by. So you're going to be doing your magic x with that part. The 8 is just going to hang out in front until you get your two binomials, and you'll tack it on the front there as well. So go ahead and try this one on your own. When you come back, I'll have the answer, okay? So pause the video and I'll see you in a few minutes. Okay, so when you factored it, what you should have gotten for your two binomials was k plus 3 and k minus 6. And then that 8 that you factored out earlier will be in the front. Now when you multiply all of this together, you should get your 8k squared minus 24k minus 144. That's the way you're going to check your answers. Alright, so this one, same thing. Is there a GCF? Yeah, they all have an x in common. So I can take that out. I get x squared minus 4x plus 1. So that's the one you're going to be doing the magic x for. And just to put this thought in there, can this be factored by grouping? We'll go ahead and try the magic x and see what you get. Okay, pause the video. I'll see you in a few minutes. Okay, so you might have been a little struggle on your magic x part because you're like, oh, I need to multiply up to 1, but I need to add up to -4. So the only thing that's going to multiply to 1 is 1 and 1. Okay? But that doesn't add up to -4. So when you can't find two numbers that actually work for it, it can't be factored anymore. So your answer is actually x times x squared minus 4x plus 1. That's as factors as you can get. Okay? And that can happen where the factor by grouping can't happen, but you can have a GCF. Okay? So even if you can only pull out a GCF, that's still, you're able to factor it. Okay? Alright, let's try another example. What if we had x squared plus 5? Okay? Well, my a would be this invisible 1 that's here. And this 5 is actually my c because the b is always with the x term. So there's no b here, which is the problem because that's what I need to add up to. And that's what I need to replace for the magic x. So when that happens and you're actually missing a term, you can replace the a, b, or c, whatever term it is, with a 0. So I could rewrite it like this, where a is still my invisible 1, b is now 0, and 5 is c. Okay? So I'm going to go ahead and do my magic x now. So I need to multiply up to 1 times 5, which is 5, but add up to the 0. So I need to find two numbers that multiply to 5 but add up to 0. Well, the only things that multiply to 5 is 1 and 5, or -1 and 5, and neither of those will add up to 0. So there's actually nothing, which means I can't factor it. So the best thing I could do is just get rid of that 0x and leave it as x squared plus 5. When this happens and you can't do anything, no GCF, no magic x, that's called a prime polynomial. Okay? It means it can't be factored at all. And that can happen sometimes. So you're just going to have to leave it where it is and let it be. Okay? Okay. Now, let's go ahead and look at one special case. I want to show you two ways to do it. So this was one of our special cases we learned last class. This is the difference of squares. Okay? It's the sum, it's the product of like the sum or difference, whatever. This is what I'm at. It's this one. The a minus b times a plus b will give you a squared minus b squared. Okay? So this, you can use this shortcut if you know it and recognize that this is a square and this is a perfect square as well. Okay? So x squared is a perfect square. 9 is actually a perfect square because I can rewrite it like this. So it looks exactly like this. And when it looks like the a squared minus b squared, I can write my two binomials like this. So x minus 3 times x plus 3. So that's a shortcut way if you actually memorize these special cases. If you don't want to memorize stuff, it's fine because you can still do it. Since we only have two terms here, we need that b term again. So we're going to have to rewrite it with 0. So now we have our a, maybe not, I didn't put it here. Our a is the invisible 1, b is 0, and c is -9. So I make my magic x, where I'm multiplying up to -9 but adding up to 0. And, well, I get 3 and -3 will multiply up to -9, and they'll add up to 0. So I replace that. I go ahead and group it. First two, last two. First two, I can take out an x, and I'm left with x plus 3. Last two, I can take out a -3, and I'm left with x plus 3. So I can undo the distributive property of the x minus 3 and put that out front. or x plus 3, and, well, it doesn't really matter where you put it. So I end up getting x minus 3 times x plus 3. So I don't know if you guys noticed this, but the stuff that you take out forms one binomial, and the stuff that's the same forms your other binomial. So you could just write it there instead of trying to distribute it out. But you could use either way, it doesn't matter. The other special case that comes like a plus b times a plus b or something, I can't remember it off the top of my head. Oh, I'm such a bad math teacher. But that one comes out to be a trinomial that has a b term, so you could just do that the normal magic x way. If you memorize it and you can understand, then it comes out to be, oh, I remember, a squared plus 2ab plus b squared or something. If you can recognize that and throw it out that way, like, and recognize it, you are more than welcome to use a shortcut. But to me, I think that's a little harder, so I just use the magic x, like a normal one. Okay? If you have any questions, please write them down. I will answer them next class. Other than that, please remember you do have a quiz on adding, subtracting, multiplying, classifying, and there's probably like 1 or 2 factoring out of GCF questions. Okay? So make sure you study for that, and I will see you next class. And I'm not going to say bye because I'm still on the big screen. But here it is. Okay. Bye. Bye.